Howdy friends, welcome back to the House of Tone. My name is Wes Lee. I'm a professional band instrument repair technician. I started a YouTube channel to show what my life is like in the trades. I appreciate you stopping by. All right, today we're starting a new series. I am so jazzed about this. This has got to be one of the coolest things that I've ever seen. Let's go see it. This, my friends, check out who it was made by. Adolphe Sax. Yep, Adolphe Sax. This is called a Saxhorn. This is a Saxhorn cornet. How cool is this? Some different lead pipes to change the key. It's in pretty good condition. I'm going to give you some backstory on it after we kind of look over some things. Somewhere along the way, the stems were changed and they used this. That's not right. It's got a lot of dents, a lot of bad dents. Look at that. Adolphe Sax. The bell is cracked right here. It's had some pretty not good dent work. The label for the pistoner or pistonnaire. I'm going to tell you a little bit about this horn. Let's go have a skull session. I just had to show it off first. I want to start with the letter that accompanied this instrument. This instrument belongs to a man named Thomas Collier. Around 1928, a man named Percy Collier came to the United States and brought this horn as a gift for my dad, Percy L. Collier, which was his nephew. Dad played this in high school band at the time. Dad died in 1987. Older sister got this instrument. When my sister died, it was passed to me. We have been able to find out, Miss Kay has been invaluable in helping me with all of this. We reached out to just a whole bunch of people. And the first person I was able to talk to was Steve Dillon at Dillon Music. Gave me some information about it. We reached out to the National Music Museum here in America. We reached out the Galfin Society and Bruno Capman Collection in Paris. Reached out to several places in France, in Belgium, in Brussels, instrument museums. Mr. Dillon was able to let me know that it was around 1855 is when it was built. And probably Adolphe Sax did not build this particular instrument. It was probably built by his sons. In 1846, that's when the first patents for Adolphe Sax saxophones were hitting. So he had transitioned to making saxophones. This instrument is called a Saxhorn. There's a family of Saxhorns. Just recently, the college in my town performed Pines of Rome, and Saxhorn would have been featured in that piece of music. It's been a really enlightening journey to learn about this instrument. I'm going to put some pictures of the catalog. I found this drawing. I think it's number 26. We found a source that said they had all of the Saxhorns, but that was debunked by another society saying that that was a scam. So we got a lot of misinformation while we were getting our information. And unfortunately, I just didn't have enough time or resources to find out any more about it. With all that being said, it's from around 1855. It's an Adolphe Sax cornet Saxhorn. The only other example that I've ever seen is in the Smithsonian. So I am looking so forward to working on this instrument. Okay, let's get into it. Now, one of the things that jumped out at me just right off the bat was the way that these stems are. This is real bizarre. And all I can figure is that someone added these stems at some point. It did not come from the manufacturer like that. They have these cork washers in here that would have set the downstroke. However, when we pull the number 2 slide, so what we can see here is that everything lines up in regards to the porting on the downstroke. And if we take this off, we take this felt off, if you look here, You've got globs of solder. So obviously the original stem, these are two different finishes. The original stem, something happened, and so whoever was tasked with repairing it decided to put these longer stems on. But I want to go a little bit further here before we start diving off into valves. When I was playing on this instrument, it plays horrible. It plays absolutely terrible. What a disappointment. I want to check this with the Magnahelic. Originally, I thought there was a ton of blow-by in the pistons, but I don't think there is. I think we have another problem. So I'm going to get the Magnahelic set up, and we're going to run some tests, and we're all going to look at this together. This is the oil that I have used to lubricate the pistons. It is for worn pistons. It's readily available. This is pretty good stuff. I put a stopper in the bell. In the Magnahelic video that I did the other day, I was only measuring the guts and the pistons. Today I want to draw on everything. The Magnahelic machine is like a vacuum pump. Gauge, we want it to go basically to zero. If you saw my video the other day, I went over how this operates. We have a stopper, close everything off. It reads zero. So what we're going to do is we're going to make a pull on the entire horn. We're going to push this in. You can audibly hear the hiss. This is a failure. This is why the horn plays so bad. Okay, we're going to start. From the mouth pipe to the end of this tuning slide, we've got a serious leak. Let's dig in and explore that. We're going to pull this tuning slide. Measures good. Okay. We're going to pull this tuning slide. We've got a leak. So, okay. Let's test the mouth pipe. Mouth pipe is testing good. Whoops. Solder joints in this slide. Let's go ahead and make a pull on the second valve slide. Second valve slide is good. Third slide is good. First slide is good. I think this slide is our real culprit. Now, the next thing I want to check is I want to check the inside port. So what we're going to do for that, we're going to set up the borescope, and we're going to check how they felt and where the piston is aligning when it goes back to the top. I'm going to go in through the bottom of the casing. And here is what we want to look at. We're looking at the number 2 piston. So what we can see is that our porting is off just a little bit. It should look just like this. This part that's the shiny part, you want to see it come up and you want it to stop right on the cylinder. When we replace that worn felt with a new felt, it's going to be great. We're not concerned about the bottom side. We're concerned with the top, because see, all that will line itself up. And this is called valve porting. I normally use a mirror, but I really wanted to show y'all what this was looking like. So it's pretty cool to see down in the instrument. So everything is well within being able to be adjusted. Now, I don't know if the finger button is original. I kind of doubt that it is, but it is the one that we're going to use for this project. I've already made a note of what this thread pitch is. I'm going to hold it in my collet, spin it on the lathe, drill it, tap it, and then I'm going to come back and I'm going to part off what I don't need. I already know where I want it to go. So I'm going to go ahead and drill, and then I'm going to tap. Here's our new stem with our counter bore. Great. So you'll see here that we have this cork washer that adjusts the height. And of course we will be redoing that. We're going to put the number 2 piston back in, and we've got our height. And of course now we got it all dirty so it doesn't want to. Well, all right, friends, thanks for joining me today. Got the pistons taken care of. Now we're going to be able to get everything ported back the way it's supposed to, have the throw feel like it's supposed to feel, and that's a good thing. We tested it. We figured out where the leaks are, so I'm hopeful now about the playability of the instrument. It's going to be much better. I'm going to go ahead and get this pulled apart. I'm going to give it a chemical flush. The next thing that we're going to be working on, we're going to be doing some dent work. This is a super cool project. What an honor to be able to work on this. Just so cool. Thanks, everybody. I'll see you next time. This is Wes Lee, signing out.